Hello everyone. In this video, we are going to use, again, our Excel tools in order to help us be able to calculate confidence intervals when we are talking about proportions and like categorical data. Okay, let's take a look. So here it says that Dax is out trying to study the proportions of individuals in Casper who went hunting this season. He randomly selected 214 people from the community and had them report whether or not they hunted this year. He decides to make a confidence interval to approximate the proportion of people hunting this season. He wants to have a 90.25% confidence level. Okay, first things first, let's bring our data over. So let's just go ahead and click on data. We're going to copy it and paste it, especially using the text option, and click OK. All right, so now we have all of this where it says hunted this season, and all the answers are just simply yes and no. In order to be able to get our how many said yes and how many said no, we're going to use a tool that we've already done, and we're going to build a pivot table. So again, what we can do is we can click Insert, and we're going to click on Pivot Table. It's going to ask us a couple of questions. It's going to say, okay, we're going to take the data from this range, and I want to put it in my existing workbook. It asks me where am I wanting to put it, the location. I'm just going to say C1, and I'm going ahead and click OK. Okay, so from here, it gives me a bunch of questions. I get this little pop-up box where it says pivot table fields. I'm going to click on the hunted this season, and it's going to go and pop up in the rows. And then I also want to drag this down into the values. So it needs to be both in the values and in the rows, both of these options, and then you should be able to see your pivot table. So here we go. So out of this, I had 214 people in the study. 83 of them said yes, they went hunting, and 131 of them said that no, they did not go hunting. Okay, so now that we have this in here, let's just put in, since we're right here, let's do our confidence level, and that is going to be equal to 0.9025 for 90.25% confidence, which means that our alpha level is going to be equal to, remember, it's just the complement of the confidence level, or 1 minus confidence level. So we have our alpha of 0.0975. While we're here, just before we move too much further, we can say that n is our sample size, and that's just going to be equal to 214, and I'm just going to go ahead and click on it. It pops up a big equation. Don't worry about it. Just hit enter, and we get 214. Okay, let's go to our series of questions. So the first one says, the 214 Casperites selected to respond whether or not they went hunting this season. So that first one is going to be our sample, which is letter C. Then it says that the proportion of the 214 individuals selected who responded that they went hunting. That is our statistic. That is the proportion of our sample. So the proportion of people who went hunting of all of Casper, that is going to be our parameter. That's the truth of the entire population. Whether or not a single respondent from the sample went hunting, that's going to be our variable, B. All people living in Casper is going to be our population, D. And the list of responses of the 214 individuals is going to be our data, E. Let's just double check our answers. C, F, A, B, D, E. Perfect. This is great practice. We continue doing this exercise for pretty much the rest of class, so it's good to be able to go through and do those. All right, next, here we say, so Dax knows that he can only use the normal approximation here in certain circumstances. Is he good to proceed with the calculations? Provide a short answer explaining why or why not. Okay, so the answer here is he is good to use it because we see at least 15 yeses and at least 15 no's. So that's kind of our requirements when we are dealing with this categorical data in order to determine whether or not we can use a normal approximation. And the rule here is we have to see at least 15 yeses and at least 15 no's. Okay, so the best point estimate for the true proportion of people who went hunting this year in Casper. So we need to calculate our sample proportion because that's going to be our best proportion, our best point estimate. So we're going to say equals, and it's the number of people who said yes, they went hunting, divided by the total number of people who went hunting. And we have a proportion of like 38%, 39%, and that is our best guess. Now, if we want a confidence interval for these guys, now we've got to do a little bit more work. So the next thing that we need is the value Q. And Q is just equal to P complement. And so to get Q, all we have to do is do 1 minus P. And that gives us the proportion of people who didn't go hunting. We're going to need that in just a second in order to calculate out our standard error. So let's actually write down our standard error next. So our standard error is going to be equal to, and let me write out the equation real quick. So it's going to be equal to the square root of P times Q divided by N. So we already have P, we've already got Q, we've already got N. We just have to put them all together now. So if we do that, that's going to be equal to square root of P times Q divided by N, and our parenthesis, and that gives us our standard error of 0.03. Okay, when we are doing confidence intervals with proportions, we always use the z distribution for our equation. So let's write out our equation. Okay, so our equation here is going to be P plus or minus our z crit times our standard error. Okay, so we've already calculated out our standard error. Now we just, I guess, need to know our z crit, and we can do our equation. So let's go right here and let's do our z crit. Okay, here's how we do our z crit. Here's our equation. It's going to be equals the absolute value of norm dot inverse. Remember, a z distribution is a normal distribution, so that's why Excel is using the shorthand of norm dot inverse. Parentheses. The thing now that we need is our alpha value. Now, since we are going to be doing a two-tailed interval for this first one, since we weren't given any direction for where we were interested for the hunters, we need to divide our alpha by 2 for our probability. So we're going to take alpha and divide it by 2 in order to find out our z critical, comma. And then it's going to ask us for the mean and the standard deviation. Now, when we're looking for a z critical, we don't put in the mean or the standard deviation for what we're calculating. It's going to be using the standard normal distribution. The standard normal distribution always, always, always has a mean of 0 and a standard deviation of 1. So when you're doing this, all you have to do is do absolute value of the norm dot inverse, taking alpha divided by 2, and then do comma 0, comma 1. End with 2 parentheses. And that will give us our z critical. Okay, at this point, we are ready to find our lower and our upper values. Okay, our lower value here is going to be our P minus our z critical times the standard error. And the upper is going to be equal to our P plus z critical times the standard error. And hit enter. Okay, the only other thing that if you want, we can also, let's just calculate it out real quick. The margin of error is equal to the z critical times the standard error. So we could do it that way. And then what that makes it is that to calculate the lower and the upper, it's just 2 alternate ways if you want to do an extra mini step. Because now all it is it's just our P minus the margin of error equals P plus the margin of error. Notice how these 2 are the same and how these 2 are the same, rounded to how many decimal places are being shown. All right, so that's our lower and our upper. And if we go ahead and click on the lower, we get, There were two. I had another program that calculated things slightly differently, so that's why I have this OR over here. But if we compare it to this first one, 0.332655, 0.332655, we're good there. And for the bottom one, for the upper value, 0.44304, 0.44304 checks out. So because we are having both an upper and a lower cutoff, this is a two-tailed problem. So let's go ahead and select our conclusion. And remember, when we are doing confidence intervals, we want to make a statement that has the word confident in it, and we want to be confident about the true proportion. So we are 90.25% confident that the true proportion of Casperites who went hunting this season is somewhere between 0.33 and 0.44. Okay, so if we wanted to say, suppose instead we wanted the confidence interval for at least the true proportion of hunters. All right, so this one, let's kind of label this right here. This was two-tailed. Kind of just label. Yeah, we'll label this for two-tailed. Okay, so we're going to now do one-tailed, lower cutoff, because we want to say at least so many. So we want the upper end to be positive infinity. If you want to say at least, it could be some value or anything above. So it goes to positive infinity. But when we are dealing with proportions, remember, proportions can only reach 100%. So that's why this upper value is 1 and not infinity. Kind of a cool thing about proportion. Okay, so our equation is just slightly different and mostly dealing with how we calculate out our equation here is going to be, for the lower cutoff, is just p minus this guy, and the z critical, instead of doing alpha divided by 2, it's the exact same thing, absolute value, norm dot inverse, probability. Because we're only throwing our error to one side, we don't divide alpha by 2, we just use alpha for our z critical. Okay, so we need kind of a new, or let's just calculate out our lower value here. So this is going to be equal to same p minus our z critical for the one-tailed times the standard error. Standard error doesn't change. That's a new lower, or 0.34468. And if we were to look at that, 0.34468. Excellent. And that's a one-tailed. And so again, we are 90.25% confident that the true proportion of Casperites. We don't want to give probability to a true value because the true value is not moving anywhere. So we want to say that we are confident of the true proportion, not confident about the sample proportion. I know what the sample proportion is. I calculated it. It's 0.3878. I'm trying to make some statement about the true proportion. Okay, last little bit here. We're almost there. So suppose instead we wanted the confidence interval for no more than the true proportion of hunters. So that would be a one-tailed upper cutoff. And it is essentially identical to this thing. Let's, we'll copy that. But instead of being plus or minus, we are going to use a plus. The z critical is going to remain exactly the same. So I'm just going to copy this because we're still not dividing alpha by 2. Paste that in, same thing. And then for our upper, it's going to be equal to our proportion plus z critical. Oops, let's do this z critical times our standard error. Hit enter, and we have this upper of 0.043. So the lower end is actually going to be negative infinity, but because we're dealing with proportions can't go less than 0. So our bottom is going to be 0, and our upper end is going to be 0.43106. Okay? Or 1016. There we go. This is a one-tailed interval. So we were able to get all of these for our proportions. And finally, we can say that we are 90.25% confident that the true proportion of Casperites who went hunting this season is no more than 43%. Okay, So now we've gone through how to calculate out confidence intervals when we are dealing with proportions instead of dealing with means. Good luck on your own assignments.